Class, you're welcome. You're welcome to this installation practicals. And now I want you to go from the explanation, from the installation you had yesterday of AC. We are connecting a solar systems in order to run this system of ours. The bell, the bulbs being controlled by the two-way intermediate switches with the sockets, inclusive. So if we connect our solar panel or solar system in the house, it should run the same system. Like if you brought the other hydro electricity, it would also run the same system. But this time we want solar to be converted into AC, and then it should run this system of ours. Now, Madame Dorothy, you are welcome to explain to us what exactly happens.
Okay, thank you, sir. Here we're having our solar components. We have a panel, we have a battery, we have a charger controller, we have an inverter. So we want to convert DC, direct current, into AC, alternating current. So from here, we get our conductors, so as these ones. We get a red conductor. We connect it on the red lid of the panel, and the yellow lid of the conductor, we connect it on the black lid. From the panel direct to the charger controller. And here we have the charger controller. The charger controller is having two terminals. We are tapping from the panel to the charger controller, following the positive and negative signs. Since we took our red lead as our positive, so when we reach at the charger controller, we shall connect in the positive terminal, and the yellow one, we considered it to be our negative. So we shall tap from the negative terminal. Then now we are supplying our battery from the charger controller. So again, we tap from the charger controller from the positive. We are seeing the charger controller is having indications: the panel, the battery, and the loads. So here now, when we are going to the battery, we take the connections from the terminals of the battery. We tap the red lead from the positive sign, and the yellow one from the negative sign. The same applies to here. Our battery is having two terminals. We are having the positive and the negative. So the yellow one from the negative lead, the negative connector from the charger controller, will be connected to the negative of the battery, as well as the red lead from the charger controller connected to the positive terminal. So here now this is the DC. So now we want to take our DC, we want to convert DC into AC. So here we will use an inverter. An inverter is an electrical device which converts DC to AC. So we are going to tap from the battery, from the positive lead to the positive lead of the inverter, as well as the negative to the negative lead of the inverter. So after connecting, then you put your inverter on, and you can be able to supply the given wiring in the storage building. It can as well work as connecting directly from the direct alternating current immediately. But here now, this one was the one which was converting from DC to AC.
Yes, thank you for the explanation. But what do you think are the functions of each of those components you mentioned from the panel?
This panel traps the direct sunlight to the battery. It bring okay it gets the sunlight, then it transfers it to the battery, to the charger controller. Then the charger controller, for it provides a central point where we connect the panel, the battery, and the loads, as we are seeing the terminals and the indications there. So this battery stores power, which was trapped by the panel. And as I explained before, that an inverter converts DC to AC power.
Now, Madam Nakiria, can you take over from there to explain how power reaches the other side of the distribution board and it is supplied to these switches here?
Okay, thank you, sir. Here we have also three conductors. Let me say three wires. We have the earthing. We have the live wire, which is called which is red. We have the earthing. Then the neutral one, which is yellow. So from here, from the inverter, I'll bring the earthing ones. I connect where the earthing is also supposed to connect it, because there is a provision for earthing this side. Then the one of the light,
She is opening because these are engineers, they are not just talking. They want to show what exactly is happening inside there, what happened inside there. Try this. And what is that system you're opening?
this one is a consumer unit.
Which is sometimes called the main switch.
So from here, have our three wires. This one, the earthing, and it is even indicated the earthing because of I've separated it with a sign here, which is a cell tape. So this one is a live wire, and the yellow one is a neutral one. So I get my neutral, and where the live provision is. So having connected like that, after connecting like this, I will be able, these things will be able to distribute to the switches and the sockets. So that when I switch on here, I will
Power.
so that when I switch off, I switch on the main switch and the inverter the other side, and the switch. I will get the ring, the light, and even the bell rings. When I come this side and I want this side, the same, but because of the power, the ring is, the sound is not producing to the bell. So the procedure continues. Yes.
Now, well, thank you. Good afternoon, class. Today, the ring circuit, I mean the interconnection, the intermediate switches and the two-way.
As seen on the board below, we are having here a main switch and sockets, two lamps, motion sensor, and some switches. So now I want us to know the procedure as they were connected. As said before, according to the project, we have a solar system, but this time around we are converting DC to AC. Well, let me go to the point. Here we have a main switch, whereby this one is the main supply from from the from the solar system. Uh, we connected 3 switches, including an intermediate switch, whereby if assuming this is a building, this is a corridor, as I'm coming like this, I can, as I come in the building, I can switch on from here. But before, we have the motion sensor, of which we don't have enough power, but it could sound. But as I'm coming in the building, this motion sensor can react or work according to the motion or the movements. But as per now, as I enter and I wanted light, I can switch on from here. Is it on?
So can we use the other which
It's
has
working.
power? It works well.
As we proceed with our project, we are on this point of motion sensor. As I said that, assuming I'm entering in a building, there is a motion sensor, and this device can detect um, movements of anything which can move, mostly human beings. As I'm entering this building, this one can detect and react. It rings. It rings like, supposing I've stepped in, it can sense and start alarming. This means that it shows someone has entered the building, and supposing he's a thief, you can detect. Then the next point is switch. As I've entered in and I wanted light, this lamp I can switch it on from here. Then as I proceed with my corridor, I can reach to this point and also switch on from the middle. Then it will give light. And supposing the corridor continues to the last destination or point, there is another switch controlling the same connection. I can switch on from here or off. If I wanted to come back, I can switch on from here and then proceed. If there is another door here or another apartment and I don't want light, I can switch off from here or on. The same applies to this one. As I'm moving out from the building, this bulb will do the same work. Switch on, switch off this one. So this is how our project is. It is illustrating or giving us the way we can control 2 bulbs using 3 switches, one gang to 2-way, also with an intermediate switch helping us within the system for alternation.
So thank you very much, Mr. Sempala, for explanations. And now we would like Joanita to explain for us how the ring circuit came about.
Here we are trying to connect. We have 2 lamps, a motion sensor. We have one gang 2-way. There are 2 switches with an intermediate switch. We are connecting a ring circuit here. And we know for a ring circuit, it comes from a distribution board, then it goes back to the distribution board. So I took this one to be my control of the socket, so that if it is on, these sockets can all work. So in accordance to my drawing here, my diagram here, they are in I can see, you can also observe it is connected in a ring form. So since it is connected in a ring form, I took this one to be my supply of the sockets. So I have here,
Don't touch it, it's on.
I have here the one acting as the live from here. It is connected here. Then the neutral is connected here. Then I looped, it came to here, then the live is here. Supply. So from here, I go to my live came, see the one here. I have this cable here, it is supplying from this side. Then this cable is supplying from this side. So which means I've got here my earth wire. I had to indicate it to become different from these ones. So I connected it to here. I have here a neutral terminal. I have here earth terminal and a live. So I need my sockets to be in a ring form. Still here the same, I connected live, earth, neutral, then live. So since I want it to be in a ring form, I have to bring it direct to here. So it will have to take off the root from here till they are alternating. So the one from here is the one here, 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 and still here. So if I try to test my sockets, they are all working. For this one, you can try. It's showing some light. You can try using the multimeter.
It's set to 750. The multimeter is set to 750 in order to.
It should not put, we know our voltage single phase is 240 and for three phase is 450. So in order to save our lives, we have to put it in the voltage which is bigger than. So I'm trying to test my sockets, see if they are working. Someone may reach nearby to observe. What is this one?
It is 330.
313.
300. It is beyond
It is beyond.
even the 240.
So if I try also test this one, 314 still. So I can try going here. I may give those a copy. It is still giving the same. So I think that's how my sockets are connected in a ring form. And what I know, still these ones are having 314 volts, which I think it is clear for us to run this circuit.
So thank you very much for the whole explanation. And what we know is that it is we are converting from DC to AC. There is a solar panel there which is trapping the sun rays, and then we have the battery which is for storage of the voltage. Then we have the inverter. We have the what? The charge controller is for what?
It acts as a central point.
Mm.
The
Oh,
panel and the
Panel
mm.
and the battery.
Yes, and then we have also the battery here, which is the charge inverter, which is converting AC to DC to
Converting AC to AC.
DC to AC, and then we have our intermediate switch, which can be applied around within the corridors or upstairs with the two-way one-ganger switch. So whenever you want to move upstairs in the storage building or longer buildings, the corridors, longer corridors, you can apply this system here. sockets which can be also used elsewhere in the storage where are also connected in the ring format. This is that the advantage of the ring format is that when one socket is off, the rest can work. Hmm? Yes. When one socket is off, the rest can work. The disadvantage is that it uses so many cables. It becomes expensive. But in the long run, it is cheaper. Because when a fault occurs in one of the sockets, the rest of the system can work. Now, of course, we have our main switch here, which is the controller, supplying power to every system here. Thank you, class, very much for this activity. You have done so well. So we meet again next time.